This will be a summarization of the eye's tracking accuracy. This was from a study and a book I wrote about the subject. The eye has a tracking accuracy of about a tenth of a diopter. It's a control system, and this is a brief summary of the tracking accuracy. The RMS is about 0.12, and the peak to peak is about 76. I will show you the circuit briefly. I have to change. The circuit must be run on batteries. RF noise is a problem for the circuit. It's been very stable. Each eye, left and right, is about 70% less than the combined combination of two eyes. So here is the basic circuit. There's a left eye and a right eye. They're identical. And they go to a summation circuit, adding to each eye separately, and the summation is placed on an oscilloscope. The total gain of the circuit is 100,000. The title is The Measurement of the Eye's Tracking Accuracy. The result was a tenth of a diopter. It has a control system. It controls itself to accommodation. And this then will explain why myopia develops in children who are allowed to put their nose on the page. There is a power supply. It's about 8 volts DC. Some 2 capacitors to keep the noise down. The ground for the 324 op amps. Op amp is about 4 volts then, half the DC. To get the AVR to read properly, you have to balance it out using a 5K resistor buffered by 2 10K resistors. So here's the circuit. There is the variable resistor. You have to use that to null out the DC bias in that circuit. There are the 1 microfarad capacitors, and there are the 324 op amps. So there are the left eye and right eye, and the summation is the 10K resistors going to the summation circuit, and there's the 10K to make the summation complete. There are the 2 lighting emitting diodes. And that is basically the circuit. And the goal was to find a reasonably accurate way to determine how all normal eyes behave using the accommodation system. It's a control system. The result is the eye has positive and negative states. And it goes negative because of that accommodation system. There's no failure. It's just a control system. Here's the DSO112A. Great scope. I did not find out the need for the DC offset or DC voltage problem until I built this circuit. And then it's necessary to null out that the average. This is analysis based on my book, How to Avoid Nearsightedness. And I think it's chapter 9. It explains basically how you go about measuring the accuracy of the entire eye, where the only signal you have is the accommodation signal So a highly accurate system, it is never defective from birth to maturity. Thank you for your review.